Okay. Fine. Today we're going to start a new topic, which is the derivative. It's a new part of the semester, new part of the course. But today we're going to see the introduction for that. The derivative has a limit. Do you remember we have seen something about this last week when we saw about the project? Remember? Yeah. We a little about this. So it's nothing new to you. Mostly. We're going to explain it. Still. Before we start, let's check some concepts we need to remember from past math courses. First, for example, what's the slope of a line?
1 over 1, right? The line power.
The rate, the inclination, no? Mostly. 1 over 1, no. 1 over 1 is just an example. Well, the slope by itself is the inclination of a line. But how can I define, how can I find it? What would be the formula for the slope? M equal to what?
y1 over x2.
Aha. So basically what this means is that the slope is going to be the change of y over the change in x, the differences. So instead of the subtraction, we usually use this symbol, the triangle. That triangle is called delta. It's a Greek letter. Delta y over delta x. Are you seeing this symbol? Physics, yeah. So delta means a change. Change of what? Change of y over the change of x. That's the inclination. Okay? Now, second concept, the secant line. What is a secant line? Remember from elementary school perhaps? Yeah, what is it? Not the function secant from last semester, no. Secant line. What? No, not that. Yeah? Yes. Secant line is a line that crosses 2 points in a curve. Okay? So secant line crosses 2 points of a curve. Okay? What points? Any points, but 2 points. They're going to cross. And what's the tangent line?
A line that only touches 4 points of the curve.
Exactly. A line that touches 1 point of a curve. When I say curve, I mean any function, or it could be a circle, like normally solve in math in the other courses of math. So touches 1 point of a curve, but doesn't cross it.
Okay. Okay. Lastly, what's a limit? Where the point to reach.
What?
The closest value can get to another one.
Okay. That's better.
Okay, nothing.
It's an operation
That allows you to approach up to a value.
yes, to approach to a value. Okay? So we're going to use these concepts for the explanation of the topic. So these are concepts that we have seen so far, Math 2, Math 3, Math 4, elementary school. So there are nothing new to you. We're going to use them to explain this. Okay? Okay, let's start then. Fine. In order to find the definition of a derivative, I'm going to explain this. Imagine that this blue line is going to be a function. That function could be any function. Polynomial, trigonometric, exponential, any kind of function. But in this case, it will be just a single curve. Imagine that in this case I'm going to choose a value in the x-axis. I'm going to call it x. If that x is projected on the graph, on the function, then I have a value of y. But that value of y has a special name because it comes from the x. What's the name of that value?
F of x.
F of x, very good. So this is going to be f of x. Now imagine that I have a second point, a certain distance from the first one. This point is going to be called x plus delta x because between the first one and second one there's a certain difference. So between them we have delta x. And if I find the image of that point on the function, now I have what?
F of x plus.
Yes, f of x plus delta x. The function evaluated at that. And the difference between them is going to be what? Delta y. Delta y. Okay? Now, imagine that from those 2 points, I'm going to draw a line, a straight line, which is going to be a secant. Something like this. You have the point, you have the other point, and we graph a line. This graph is going to be a secant line because it crosses 2 points of the graph. Okay? Now, if I want to find the inclination, the slope of that secant line, what will be my formula?
F of x equals to
First will be delta y over delta x, as we saw. Okay? But the delta y is what?
X plus delta
Yeah?
minus
Minus
f of x.
f of x. Yeah, because it's the whole distance to this value minus this one is the difference. Y2 minus y1. Over delta x, and delta x is x plus delta x minus x. Okay? But we can just leave it as that because those two x's are going to be cancelled. Okay? I can cancel this x and this x and I obtain the original one. So it's going to be f of x plus delta x minus f of x over just the single delta x. Okay? That's the slope of the secant line. Of the secant. Of the secant. I haven't finished yet. And slope. Okay. Can I continue?
yes.
Yeah. Okay. Now here comes the tricky part. This is not a derivative yet. If I want to find a derivative, what I'm going to do is this. I'm going to transform that secant into a tangent line. Okay? In this case, this secant touches 2 points. But if I want to transform this secant into a tangent line, I need to have just a single point, a single tangency point. How do I do that? Simple. I'm going to leave this point here as my tangency point, the touching point of the tangent and the curve. And I'm going to move this point little by little, so that point is going to be covering this one. In what way? For example, if I were to move this point, let's say here, now my line is going to be closer to being a tangent. If I move it here, close to being a tangent, until you have this. But the thing is, if I want to move that point, I need to change something. What is it changing if I move the point? What changes if I move that point? What part? The slope is going to change, yes, but since this x is my independent variable, if I want to change this point so that point covers this one, I need to do something to this distance. What happens? I need to decrease it. Decrease it little by little, so at the end I have a single point, which is this one. Okay? So, this distance is going to be decreasing. Until what? Until I have a single point, which is this one, my near this. If I have that, now I have my tangent line. You don't get it?
No.
No.
Okay.
Can you explain like
Again, the idea, the objective is I have a secant. I have 2 points. What I'm going to do is I want to transform the secant into a tangent. What's a tangent? Just one single point, not 2. I cannot just disappear this. I don't want to disappear that point. I want to move it. The blue line is going to stay the same. I just want to move the point. For example, if I move this point to this point, then I have a different inclination, yes, but it's still a secant. But what did I do to obtain that? To move to this point, what did I do with this distance? Decrease it. Why this one and not that one? Because that one depends on this. This is independent variable, the one that I can modify. Okay? I'm modifying this one. I'm decreasing this one. So I have this point now here. If I decrease it a little more, now I have another point here and we have another secant. Little by little, I'm decreasing this distance until you have a single tangency point, which is this one. But when does that happen? When does this point cover this one? What happens with this? Okay, you could say that if this distance is 0, these 2 points are in the same point. Yeah, so now you have a tangent line. But the thing is, according to this formula, can I put this distance to be exactly 0? No. Exactly. The idea is that this cannot be 0 exactly because it doesn't exist. It's undefined. But that's why we need to use the limits. With the limit, I can approach this distance as being as close as 0 as possible. And with that, I'm going to obtain something close to a tangent, which is the thing that I want to do. Do you get that now? Okay, so at the end, this red line becomes a tangent if I apply what? If I apply a limit. So my slope of the tangent line, not the secant, the tangent line is going to be approximately what? A limit. For a limit of what? Approaching what?
0.
With what? What do I need to approach to 0? Delta x. Not x. X no. X is the value. Delta x. So delta x is going to approach to 0. Of what? Of this? So the limit of f of x plus delta x minus f of x over delta x. By doing this, what? By doing this, I'm going to get the slope of the tangent line approximately. Okay? Do you get that?
Yes.
Okay. This formula is going to give us my derivative. Okay? This f apostrophe x means derivative. Derivative of the function. What function? The one that I'm checking, f of x. This is called prime. So it's f prime of x. And the formula for that is going to be this.
This is un
No, no. I need this one here. Of course, that depends on this. But you can modify this as independent variable. But this is going to change because of this. When you change this changes also because of this. Okay. Yes or no?
¿A qué se refería con lo de que no lo usa la definición? What doesn't proceed? Que en la definición de tangent line dice what doesn't proceed. Ya lo recuerdo. No, sí, sí. Pero ¿a qué se refiere con eso?
No, but you only touch the Okay. Listen.
Mr. And why is the answer a derivative of
Okay. Listen. Okay. That's the definition usually use of a derivative. Okay. But usually most books, most exercises don't use delta x. It's a little confusing.
Yes.
So instead of using delta x, we're going to use another letter. We're going to use h. So this formula is going to change a little. The derivative is going to be the limit as h approaches 0 of what? F of x plus h minus f of x over h. And that's what? That's the definition of a derivative. Okay? That's the formula. That's the formula.
Profe, otra vez, ¿por qué no se puede que era aproximado?
No, you need to approach the 0.
Pero, o sea, porque el resultado nos da aproximado o porque
You mean this? Okay, because for this to be a real tangent, the distance should be 0. There is no distance between one and another. But according to this cannot be 0. It doesn't exist. So that's why this is just an approximation for the log line. A very good approximation, but it's approximation. Okay? Fine. Yes? Now, listen. All of this explanation is for you to try to define a derivative. Tell me, from all of this explanation, give me in your own words, what would be a derivative then? What's a derivative? What? Almost. Almost. Okay. Fine. Listen, the derivative has two definitions. The mathematical definition is precisely that. It's not just the slope, it's a function for the slope. It's a function for the slope of the tangent line. Of a function of f of x, let's say. Okay? Why a function? Why not just the slope? Because, and you'll see with examples that the answer is not going to be always a number. The slope can change depending on what? The slope can change depending on my choosing of the value of x. But the derivative is going to be always the same. The slope, no. The derivative is going to be always the same, but the slope, no. The formula is going to be. You'll see what I mean with an example. That's one definition. The second definition that you already checked in your projects, supposedly, is that the derivative is going to be an instantaneous rate of change. What do I mean by instantaneous? For example, here in physics you already seen graphs for velocity, positions, all of those things. For example, if this function represents the position, the difference between those 2 points, the rate of change of that is going to be the velocity as an average between two values. But when I get the tangent, since it's just one single value, it means that it's instantaneous. That is at that exact moment in time, not as an average. That's what it means by instantaneous. Okay? I don't need you to memorize the definitions. I need to memorize this at all. I want you to understand. Okay? Because I'm going to use these concepts in the next topics. And I'm going to explain again because I already explained.
That's when you can get an average if you get the secant.
The secant is an average, precisely, and the tangent is an instantaneous rate of change. Okay, you can answer your G63 about that, and it's going to answer the same thing. Okay, questions? About the explanation? Not that complicated. Yeah, but the explanation. As long as this becomes tangible. That's why it's close. Because they always close. Okay.
Profe, siempre que la función primo de x es referente a la tangente, ¿no? O no se puede a la secante.
No sé, o sea, pero sí.
Not the time. The function for the slope of the time. We refer to the time. Good. Can I go this?
Yes.
Fine. Example. You have a function x squared minus 2x plus 1. The question is, for the derivative using the definition, the formula. The one in red in there. What do I do? The derivative equal to. I need to apply that formula to this function. It says limit x approaches 0, that's always the same thing. But then it says f of x plus h. What does that mean? That means that I'm going to evaluate this function with x plus h. What does that mean? That instead of x, every that I have, I put x plus h. So x plus h to the square minus 2 times x plus h plus 1. That's just the f of x plus h. Then it says minus f of x. So what do I do? Minus the original one. So minus x squared minus 2x plus 1 over h. Okay?
You apply the tangent
Therefore, the function that I have, all of this is f of x plus h. All of this is f of x.
Teacher, is it always going to be h equal to 0?
Always. Okay. That's the formula applied. Questions?
No.
Sí,
Okay.
yo no entendí por qué no sacaste, o sea, tomaste las horas de f o x plus h.
Yeah, it means that for every x that I have in my function, now I put x plus h. X instead of x plus h to the square. Instead of x plus h times 2 plus 1 minus f of x, which is the same as the original. Okay, now you have a limit. The ones that we did now to get to 0.5. What do I do now?
So,
You substitute, so directly the answer is going to be 0 over 0.
so then you factorize.
Yeah. Here equal to 0 over 0. Before I continue, remember, it's always substituting, so you have 0 over 0. You need
¿Sustituimos por H o por
no h. Always h. Always h. Now what? Whatever applies. So in this case, we have an element to the square, this one, and you need to expand everything. So, limit h approaches 0 of x squared plus 2xh plus x squared minus plus 1 minus x squared plus 2x minus 1 over
You cancel the x squared.
yeah x squared with minus x squared. Anything else? Minus 2x with 2x.
1 over 1.
1 minus 1. So I just have 2xh, h squared, 2h. Can I factor something there?
Yes,
Yeah. H multiplies 2x, h minus 2 over h. Can I simplify?
Yes.
Yeah. So now I have limit h approaches 0 of just 2x plus h minus 2. And lastly, I evaluate it again. So the answer is
2x minus
2x minus 2. This becomes 0, so 2x minus 2. That's my answer. That's my derivative. The derivative of that function is 2x minus 2.
Oh, that's wonderful.
Questions?
No.
No, right now, just for this, no. That's no derivative, that's the answer for this. So the answer is equal to this.
Wow.
And that is the slope.
No. No. That's the function for the slope. That's not the slope, because you have an x. That's the function for the slope. Yeah, if I have a value or another something. Yeah. That's not the slope. Good. Questions? Yeah. Okay. Listen. In your projects, perhaps you have seen short rules to find a derivative. There are rules. But the idea is that now, at this topic, we're going to use the limit definitions. You can find a little better. Later, next partial, we're going to use the simple rules, but the partial are going to be more complicated. Okay, right now there are easy functions, long procedure. Next partial, complicated functions, short procedure.
So we have to follow that one. If we follow the short ones that we learned around the project, we have to follow that one.
Listen. The exam will be like this. The exam will say derivative is limit definition. If I say limit definition is the long procedure. Next partial, when I say find a derivative without this statement here, then you can use the short procedure. But we'll teach you that next week. Okay. Next example. This example is more like the quiz. It's not just a derivative. The instruction says you have a function, which in this case is different, square root of x. You have to find the derivative, it's a limit definition, the whole process. Number two, we're going to find the slope of the tangent line at a certain value. Number three, we're going to find the equation of the tangent line. And number four, we're going to graph both. Function and the tangent. Okay? Very easy. Yes, it is.
Teacher, what do you write F from
Fine. Okay. Derivative. F prime of x equal to limit h approaches 0 of what? The function is different, so it's going to change a little. Of what? Square root of x plus h minus square root of x over h. It's the same formula, but now the function is different. That's why square root of x plus h minus square root of x over h. Equal to what? 0 over 0, yeah. You have that, so what's the next step? Rationalize, good. Limit h approaches 0 of square root of x plus h minus square root of x over h times what? Plus square root of x over the same. Remember, if you have square roots, you need to rationalize, you need to multiply times the conjugate of the binomial with the square root. Okay? Equal to what? Limit h approaches 0, x plus h minus x over h multiplied plus square root of x. Can I cancel something?
Yes.
The x's
Can you cancel the h?
and simplify the h's, yeah. So at the end, I just have 1 over square root of x plus 0 plus the square root of x. What did I do? I simplify everything. I already evaluated the h with 0. Okay? Can I simplify the denominator? Yeah. So the answer is going to be 1 over 2 square root of x. That's the derivative. That's the derivative. Questions?
How do we write some process like
What's second part?
like wait, this is we all write down the eliminate them. So can we skip to write
X minus x?
Yes.
Have just a single h.
Yes, but can we only instead of writing the whole process, can we only write the other part, right?
Instead of from here, like this directly?
From that one directly to that.
Fine, no problem. Just make sure to remember, if you have the h, do the limit. If you don't have h, don't do limit.
Yes.
Yeah.
Profe, la instrucción no la de que encuentres la slope, todavía no haces caso, ¿verdad?
For the first part, for the second part, yeah. Okay, fine. Number 2 says, find the slope of the tangent line at x equal to 4. If the derivative is the function for the slope, and now I have a value for x, and I want to find the value of the slope, what do? Substitute. The slope of the tangent line is going to be the derivative evaluated at 4, the one that I have. So it's going to be 1 over 2 square root of 4 equal to 1 over 4. That's the slope at that value. That's what I said, that is only the function for the slope, because the slope itself is going to have a value. The derivative is always the same. The slope will change depending on the value of x. Is that clear?
Yes.
Good. Number 3, it says find the equation of the tangent. If it's a tangent line, of course, what's the form for the tangent line? What's the standard form of a line? Yeah. So I already have the slope, right? Which is m directly. Do I have x? Yeah, that's 4. I need to find b. Question, do I have what?
No.
No. Can I find what?
Yes.
How?
With the slope and the x you have.
But I also need b. I don't have b.
Substitution
And b is not 0.
equal x to 0.
No. Listen. Remember that I told you in the explanation that the graph and the tangent line, they share a point, the tangency point. Okay? In this case, I'm giving you the x-coordinate of that tangency point.
So you have to.
So how do I find the y of that tangency point? Putting this value in my original function. To find the y, then it will be the function evaluated as what I have, 4. So it's going to be the square root of 4 equal to 2. Okay? The tangency point is 4,2. Now I have everything. Can I find b now? Yeah. 2 equal to 1/4 times 4 plus b. 1.
¿Por qué raíz de 4? Sustituyes con la original.
Yeah, I found 2. That's my y for this. Because remember, the tangency point is shared by both the graph and the tangent line. How much is b? 2 minus 1 is equal to 1. So my tangent line, the tangent line,
Y equals to 1/4 x plus 1.
that's a tangent line.
And then you just graph.
And then we're going to graph both the tangent line and the function. Questions so far? No? ¿Cuál 4?
Ya es igual a
2 o 4? ¿Cuál? 4. You put the value in the original function, substitute, that's your y.
Pero ¿por qué?
Because this is x and this is y. Remember, you have a function, you have a tangent line, you have a point that they share, the tangency point. Okay, so you already have the x-coordinate of the tangency point. You want to find the y coordinate of the tangency point, what do? You put this in my function, with y. And that's the one that you're going to use to find the v of the tangent line, which is this. Yes? Okay, now graph, watch. Okay, go.
Profe, ¿y M no se necesita sacar?
What?
M, la ecuación de la slope, no se tiene que sacar. ¿Es un cuarto?
X is 4. Okay. Now what? How can I graph the function? Square root of x. Okay? Remember, the square root is half a parabola, half horizontal parabola. So it's 0, 0, 1, 1, 4,2. Do you know why? Just give values to it. You have a square root. Square root of 0? Square root of 1? Square root of 4? Remember, you're going to graph in the exam, so. Okay, that's what? That's the function, f of x equals to square root of x. How can I graph the tangent line? Y-intercept is 1. And what else? You can use the slope if you want to. It will be 1 up, 4 to the right. Rise and the run. Or you have another option. You already have the y-intercept, which is 1. and you already have another point of the line. What will be the other point of the lines that I have? 4,2. The point that I have for the tangent line is the point 4,2. Why? Because it's the point on the graph of the function and on the tangent line. So it's here. I'm giving the line. And the answer, same answer.
Teacher, can you repeat that? Teacher, can you repeat that?
Wait. No. Pay attention. Okay. I'll repeat again. Pay attention. I graph the blue line, which is the graph, f of x, by giving points to it. If I want to graph the tangent line, what do? Like a line. This is the y-intercept. So 1. And then you can use the slope if you want to, which is going to be 1 and then 4 to have another point. Or you have another option. You already found the point in the tangent line. That value here that I gave you at the beginning is a point on the tangent line. And the one that I found is the y-coordinate of the tangent times the point. So you can also use that, and that point is going to be shared by both the graph of the function and the graph of the tangent line. So you have another point. Do the line. It's going to be a line. Yeah.
When we graph the x, we have to put which function.
Yeah, please. And let me say something to you. In the exam, I'll give you a grid, quadricular. Yeah, in this case, I don't have a grid here, so that's why the graph is not as perfect as I want to. But in the exam, I want the graphs perfect. What do I mean by perfect? I mean that the tangent line has to be the tangent line.
You can search.
No?
Pero
But you want to 100, yeah.
o sea, te podrían dar otro valor de x para encontrar su
Yeah, exactly. If I give you another value of x, the tangent line is going to be different.
O sea, y
But
pues
the
la
derivative is the
pendiente
same.
cambia también.
Ah?
Y la pendiente cambiaría.
Of course. So, if I give you another value of x, this is the same. This doesn't change. That's the answer for that function. But the point is going to be different, the slope is different.